Hi guys, how are you? So in that lecture series we are going to see how we can utilize the Word2Vector model from the scratch and how you can retrain it. So before that I will going to try some points related to Word2Vec. So it's a predictive base, it's a deep learning base, and it has two types. One is Semantic and another one is skipgram. So basic difference between both of them is Semantic will going to predict target word based on the context of word. So here context of word is necessary. So based on the whatever window size you are giving, based on that it will be going to give the predict the that target word. And in skipgram what happens, here we give the target word and based on that we predict the surrounding word. Just ignore this spelling mistake guys. Okay, so please remember, so how you can create your own word embeddings. Many times in the interview or while you are working in actual company, that time you have need to create your own word embeddings. So please remember, so you can create word embeddings by various methods, by using TF-IDF, count vectorizer, Word2Vec, fast text or blocks. But most of the times Word2Vector embeddings are very good as compared to that TF-IDF count vectorizer, because those do not contain the semantic meanings, contextual meanings. So those are only a frequency based, but Word2Vector has a lot of advantage and it's creating the vectors. So please try to tell that difference and please remember it, that's also very useful in your real life. So what libraries you required? You required the NumPy libraries. Then you can import that Word2Vector model, that from that gensim model dot import Word2Vector. After that you have need to use that some punctuation and tokenization from that in LTK library. Okay, after that suppose you have a lot of sentences or you have your database. So please remember, your sentence or whatever you want to train data, that should be in a list format, and in the list there should be all those your sentences should be separated like that. Otherwise, suppose if you have a lot of paragraphs or text data, simply instead of doing this manual work, I will write here. Simply you can use here, I will write here, simply use NLTK dot sentence tokenizer. Okay, so what it will do, based upon the that dot or comma, it will going to create all those split your sentences like this one. So sentence tokenizer will work like this one, means it will going to give you data like this. Okay, after sentence tokenizer you have need to do the word tokenizer. So for the word tokenizer, NLTK also provide the libraries, that NLTK dot word tokenizer. Okay, so remember NLTK dot word tokenizer. Okay, so please remember here that now what we have doing, that from this sentence we are taking each word. Okay, so in that tokenized sentence you will going to get the list, and in that list you will going to get all those words. Okay, so while training the Word2Vector model, please remember you have need to pass some parameters. As you know, Word2Vector based on the embeddings, means it creates the vectors. So please remember you have need to give these some dimensions. So first one is the tokenized sentences, means whatever you have created, you have splitted your sentences into the word level, and those words should be passed into in the first parameter. Okay, after that most important is the vector parameters, means vector size. How many vector numbers should be provided for each word in your that sentences. So if higher the number of dimensions, higher the number of vector size, more will be model try to learn all this very well. But sometimes if you have very less number of those dimensions, that time model definitely will going to do overfitting. And if you have complex data, that time please try to increase number of dimensions. So many times you may be figure out what will be the criteria and what amount should be dimensions. So dimensions vary from 500 means from 50 to the 500 to the 1000s. There are so many, means large language models have so many thousands dimensions, but for the Word2Vector you should try to keep those lengths between 100 to 500, and most of the times it's work well for the 300 dimension. Okay, after that you need to give the window size. Window is nothing but, as the Word2Vector automatically utilize the CBOW methods, and in that CBOW methods you have need to pass the surrounding words. So window is nothing but the surrounding words, and based on that it will going to predict the target word. And minimum count is nothing but how many repeated words you have need to pass here. Suppose if you give count is equal to, then it will going to take only those words which have a frequency or count 2. Workers is nothing but how many processes you have to utilize. Okay, then once you will load that model, then model will going to give those, model will going to train, learn, and it will going to save all those words vectors. So you will going to consider if I have done this course, if I have utilized that numpy dot zeros, and if I have created that dimension here is nothing but 200, means if I have created 200 zeros of numpy. Look, for the Word2Vectors it has also issues such as out of vocabulary words. There may be some words which are not given vectors by the Word2Vector model, or those words may be excluded. Such to give all those words some specific dimensions, indirectly we can fill those out of vocabulary words by the 0 dimension. So that's purpose we are utilizing that 0 dimension, and we are taking all those words from that tokenized sentences, and we are finding if any word not getting dimension, that time we are just passing all those numpy zeros, and at the last we can pass any word or letter, and we also get to know that how each word has vectors and all this. And at the last, whenever you print the shape, that time also you can get the whatever dimension we have given, that type of dimension you will get. Actually I don't know, but now I am facing error to download the punctuation mark, that's why it's not giving the result. But here actually I have given some conditions. Here you will going to see, here I have just given the sentence like that one, but please remember sentence should not be like this one, it should be in the list format. Okay, this time I am doing this list. Okay, and and after that it should also going to create, I have need to do a tokenization for that list. I don't know it will work or not, because I have created those sentences, and those sentences should be converted into the words, but here we have directly passes all those sentences. Still it has given all those results, and I have tried to predict the vectors for the Y world, and it has given like this one. So I hope you have understand the basic theory working, and please remember those parameters. While creating a Word2Vector embeddings, you have need to pass that vector dimension, then window size of the surrounding word. Here you can change that also, but please remember there should be sentence length like that 10 means, and workers is equal to 4. So we will get all those results and dimension. If I print that shape of that dimension, it will also going to give the 200 vectors. And you can save all those by using that model.save command, model.save. Here you can pass vectors, then automatically you can see in the directory. Here you will going to see that vectors has been saved in the name of vector. I think it's open in a different directory, that's why it's not showing. model dot wv dot okay. So I will in the next lecture I will tell you here actually this is showing. I hope you understand. Please try to understand that theory in the real practical world and you will get to know. And what are the its use cases? You can use it for the find the similar word, cosine similarity, most similar word, and all those. I hope you have understanding and enjoyed the lecture. If you have any doubt or correction, please tell me. Thank you. Bye bye.